Hi, my name is Miss Vu, and today we're going to look at the product rule. Let f of x equals to two functions, f of x and g of x, multiplied by together. Now, if these two have derivatives, so f dash x and g dash x, then the derivative of f of x will be f of x times the derivative of g of x plus the derivative of f of x times g of x. So leave the first part, derive the second part, plus derive the first part, leave the second part. Now, Leibniz is another mathematician that came up with this, and his notation is slightly different. It doesn't matter which way you write it, but it does the same thing. So instead of writing f of x, if you wrote y equals u v, where u is f of x and v is g of x, then deriving that, instead of the apostrophe we have dy dx, we will leave the first, so f of x, see? So u is there, derive the second, so dv dx, plus leave the second, okay, g of x doesn't get derived there, so we leave v there, and then derive the first, du dx. So it doesn't matter which of these you use really. We'll be writing that at the top corner of each page, and we'll be using that. Also, do know that it's a plus sign, so it doesn't matter if you have this term first or that term first. And I'm actually going to switch these two around in the next page, because that's how we're going to learn the next formula in the next video. So it'll help us with that. But the reason I have it in this order is you'll find that most textbooks have them in this order to start off with. Let's do some example. So you have derived the first, left the second part, and left the first part and derived the second part. We're going to use this today. Now here's the first factor, 2x cubed plus 16, so that's going to be our f of x. And here's our second factor, 10 minus x squared. That's going to be our g of x. Before I write the answer, I'm going to derive these separately so we can refer to them, but you don't have to do this step. So deriving that, 2x cubed becomes 6x squared, and deriving that we have minus 2x. So we don't have to write this part, you can go straight to the derivative. So derivative would be 6x squared, this part, times g of x, that part. And then plus this part, the derivative here, times the first part. And now of course you expand. So 6 times 10, 60. 6x squared times minus x squared is minus 6x to the power 4, and expanding those we get that. Now collecting like terms, we have minus 6 and minus 4, so that's minus 10x to the power 4, and remember we like to put things with the highest power first, so then 60x squared and then minus 32x. Let's have a look at how we do this on the CAS calculator. So writing out ddx in our keyboard. So go to math 2, ddx. Now being very careful with our brackets, we have 2x to the power of 3 plus 16, and the other factor 10 minus x squared, and then enter, and we obtain the same answer. Let's do another example. 5x squared times 3x minus 1 squared. Now you'll notice the first part is easy, 5x squared becomes 10x. But the second part we have to use the chain rule. If you've forgotten the chain rule, please look at the previous video and have some more practice before continuing, because we're combining all the rules and it's going to be more complicated. So to derive this, we derive the inside, so 3x becomes 3. Then we multiply it by the derivative of the outside bit, so 2, bring it to the bottom, and subtract 1 from 2 becomes 1, keeping that all together. So we have 2, 3x minus 1 to the power of 1. Now expanding that, we have 3 times 2 is 6 times 3 is 18x, and then 3 times 2 times minus 1 is minus 6. So now we can apply the product rule, so the derivative of the first part times the second part, and the derivative of the second part times the first part. So now we can write that out, so that times that, and then plus this times that. Then we can expand. Notice it's a quadratic, so we'll expand that first. and we just multiply through those two. So 5 times 18 is 90, and 5 times 6 is 30. That's just a quadratic, so 3x squared is 9x squared. Then 3x times 2 is minus 6, because of a minus there, and then the 1. So expanding that, multiplying by 10x, we have 90x cubed. Then 10 times minus 6 is minus 60. 10 times 1 is 10. Then rewriting that. Now collecting like terms, we have 90 and 90 here. X cubed, so 180x cubed. Then we have minus 60 and minus 30, so minus 90x squared, and then plus 10x. Now have you noticed that we could actually expand this? So we expanded a quadratic to 9x squared minus 6x plus 1, and expanding that further, we obtain this. So 5 times 9 is 45, 5 times 6 is 30, 5 times 1 is 5. Now, from this, we can derive it normally like we did previously by bringing 4 to the front. So 4 times 45 is 180. Subtract 1x cubed. Then 30 times 3 is minus 90. Bring down the power by 1, we have x squared. And then 5x squared becomes 10x. So you can see from this that the chain rule and the product rule definitely works, but also you could have expanded it. Now in this example, expanding it looks a lot shorter than doing all of this, but obviously we've done this so that we can see how the formula works as well. Example 3. This time we have to use the chain rule for the first part again. So we have x squared minus 1 to the power of a half. So deriving the inside first, we have 2x times, deriving the outside, bring the half down. So 2x times half is just x. And then minusing 1 from the power, a half minus 1 is minus a half. So it will be x over that. Since minus a half, you can make it positive by bringing it down to the denominator. So x over all of that. The derivative of the second part is easy, 3x squared. So again, using the product rule, we have the derivative of the first part times the second part. And then we have the derivative of the second part times the first part. And now we can simplify. So we multiply all that through, and multiplying that by that over that means we have 3x squared times all of that. So now we have the simplified version there. You can also use the CAS. Now we have e to the power of negative x times 1 minus 5x. Again, to derive the first part, we have to use the derivative of exponentials. So bringing the minus to the front, we have minus e minus x. Deriving that just gives us minus 5. So this times that is our first part. So minus e minus x times the second part. And then the second part is this times the first part. And now we can simplify all of that by noting that there's an e to the x, negative x as a common factor. Take that out, so bring that to the bottom. We're left with minus 1, positive 5x, and then minus 5. Minus 1 and minus 5 is minus 6. So you can further simplify to that. And remember, we always like to have positive powers. Here we have 2 examples. You can pause the video and try them out yourself, and then unpause to check the answers. So the derivative of the first part is 6x, and the derivative of cos is negative 7 sine x. Now putting it all together, we have 6x times cos 7x, and we have negative 7 sine 7x times 3x squared. I'm putting the brackets there, but you can always put the 3x squared at the front so that you don't mistake the 3x squared for something inside the sign. And can you simplify this further? Well, we can bring that to the front. 3 times 7 is 21. Let's do this one over here. Notice that sine x squared is the same as sine x all squared. So now deriving the first one is derive the inside, so sine becomes cos, and derive the outside, so 2 sine x. So again, that's the chain rule. And now let's derive the second part, cos 7x minus 11. The derivative of cos is just negative sine, and bring the 7 to the front. So now we take this times the second part and takes this times the first part. Just writing it out. It looks very long, but it's exactly that. So this times the second part and that times the first part. Remember it's plus, but since there's a negative there, it becomes a minus. Now you can simplify this further using the cas and 2 cosine x sine x equals to 2 sine 2x, which is one of the identities, but it's actually not needed in the answers to get full marks. One more example. Here we have 2x cubed cos 1 of x, and we're looking for the derivative of that at 1 over pi. So we'll find the derivative first. Again, divide the first part, which is 6x squared. Derive the second part, cos of another function. So we have cos becomes a negative sign, and x to the minus 1 becomes minus x to the minus 2. But since cos becomes minus sign, the two negatives disappear. So now we have this times that and that times that. So just write it out. So 6x squared times cos 1 of x and all of that times 2x cubed. Now we can simplify that by taking the 2x cubed to the front. You're always welcome to write that at the front. I'm just sticking to this format so I'm consistent. So when you're looking at the working out, you can match it easily. But if I was to do it by hand, I would actually write the 2x cubed first because I know it's got nothing to do with sine x, and I'll have to multiply by the factor in front of sine x. So now plugging in our value, we have that, but we know cos of pi, so pi is here, is negative 1, and sine of pi is 0, so that part there disappears. And this part here, negative 1 of all of that, is negative 6 over pi squared. Thank you for watching. It's going to be a little bit tricky for equations like this where you have to do the product rule and the chain rule. So please try this question again on a separate piece of paper and make sure that you get to the same answer. Bye!